A particle initially at rest starts moving in a straight line with an acceleration a of 8 plus 12t, which is measured in meters per second. Then what we're told to find is the distance covered by it in 3 seconds. So want to see how we can obtain the distance given the acceleration, which is a function. Now one thing that we need to know about distance is that distance is simply the length between 2 points, and magnitude simply gives us the overall change in position. So we can say that distance gives us the size of the displacement, that is neglecting the direction. So the size we get for the displacement or the magnitude gives us the distance. Now we not say velocity is the rate of change of displacement, where we divide displacement over time, and if it's given as a function, it will mean that it will be the derivative. We're going to differentiate x, that is with respect to time, where x represents the position. Now this process in mathematics is known as differentiation, and that is under calculus. Okay, now if we want to obtain the acceleration, what we do is we differentiate the velocity with respect to time. Now from this problem, what we are given is the acceleration, and we are simply told to find the size of the displacement. So what we're going to do is we're simply going to reverse the process in order for us to find the position, which is the distance. So we'll move from acceleration to simply distance. So we have to reverse the process. Now this reversing of the process being that for us to move from the position to the acceleration, we need to differentiate. So in this case, we'll move from acceleration to velocity, then the displacement. So to do this, we're going to integrate. So we find velocity by simply differentiating acceleration. Integrating acceleration, sorry. So we're going to reverse the process by moving from acceleration to velocity. Now acceleration in this case is given as 8 plus 6 plus 12t. So to obtain this, what we're going to do is we're going to integrate our function, that is with respect to time. Now in a case where you're integrating, the method that we use, suppose we're given the integral of a function is ax to the power n being integrated with respect to x. What we do here is we get the same integrand we have, then we add a 1 to the power, then we divide with the same, then we add a constant of integration. So c is known as the constant of integration. Okay, so this is the same formula that we're going to use in integrating the acceleration, which helps us to obtain the velocity. So we're going to say 8. 8 is the same as multiplying with t to the power 0, because t to the power 0 is 1 and giving us power 8. So to the power of t, which is 0, we're going to add a 1. Then we're going to divide with the same. Then from there we add with, here we have 12t. So we're going to say, where n is not supposed to be negative 1 because the quotient will be a 0, will be undefined. So then to t we add a 1, then we divide with the same, then we add a constant of integration. Now this will come out as 8t, then you add with 12t squared divided by the same 2, then plus c. So this further simplifies to 8t plus, so 2 goes 6 times in 12, so you have 60 squared, then you have a c. Now being that we're starting from rest, our c is 0. Our c is 0, so mean we're going to have our v to be equal to 8t plus 60 squared, being that c has been equated to 0. So we'll remove our c there. So to obtain the position from velocity, we're going to simply integrate again. So we say x will be the integral of what we got for the speed, or for the velocity rather. So this is with respect to time. Now this will be the integral of what you have for the speed, which is 8t plus 6t squared. So we're not adding a c there because it's a 0. Then this is with respect to t. Now what we have is 8t, the power is 1, so you add a 1, then you divide with the same. Then you say plus 6t squared, to the square you add a 1, then you divide by the same 2 plus 1. As usual, since we're integrating, add the constant of integration. Now our x will be, our x therefore be equal to 8t squared divided by 2, then plus 6t to the power 3 divided by 3 plus c. Now our x will be equals 2 into 8 goes 4 times. Okay, sorry, this is an error. So let me erase this one. So we're going to get 4t squared plus 3 into 6 goes 2 times, then t cubed, then you add a c. Now being that it is starting from rest, our c will just be a 0, giving us the position to be 4t squared plus 2t cubed. Now this is the displacement. Now we're just looking at the size, we're not interested in the direction. Now this is what we get in terms of the function. Now we're told to find the distance that is at t equal to 3 seconds. So where there's t in the function of x, we're simply going to replace with 3. And this will simply give us 4 to multiply with 3 squared. Then you add with 2 multiplied by 3 to the power of 3. Now 3 squared gives us 9. When you multiply by 4, you get a 36. So there we have 4 times 9, then plus 2. 3 to the power 3 is 27. Now what you get is x will be equal to 4 times 9, that is 36. Then you add with 2 times 9, that is 54. When we sum up these two, we get x to be equal to 90. And we not say distance is measured in meters. So our distance is equal to 90 meters. Thank you very much.